Okay, so in this video, what we're going to do is we're going to take a look at an example of a very simple projectile motion problem. And the problem reads, a small ball rolls horizontally off the edge of a tabletop that is 1.2 meters high. It strikes the floor at a point 2.5 meters horizontally from the table edge. So we're asked to find A, how long is the ball in the air, and B, what is its speed at the instant it leaves the table. Okay, so the first thing that we want to note down is the pieces of information that's already given from the problem. Okay, so the first piece of information is y0, right? We're told that the tabletop is 1.2 meters high. So immediately that tells us that y0 is equal to 1.2 meters. Now it tells us also that the ball strikes the floor at a point 2.5 meters horizontally from the table edge. Okay, so this gives us the landing distance x of the ball. So x is equal to 2.5 meters. Okay, now another thing that we can get from the problem, it doesn't explicitly state it, but you can see that the ball has only an x velocity and no y velocity. Okay, why? Because the ball rolls horizontally off the edge of the table. So this tells us that v0y must be equal to 0. Okay, so this is very helpful information that you can get from this problem, because in many problems you won't be explicitly told these kind of things. You have to sort of read the problem and then be able to come about that conclusion on your own. So it's very good to look through these problems and see if you can read between the lines to get other pieces of information that aren't explicitly stated. So with this information, what we can do is we can take a look at some of the y direction formulas, okay? And we can consider v0y to be 0. And if we do that, a lot of these formulas become a lot simpler to read. Okay, so if you take a look at equation number 2, you'll notice that if you input v0y equals 0, you end up with y is equal to minus a half gt squared plus y0, right? Which is good because this form of the equation means that we only have one unknown. Okay, and that unknown is t. The reason I say we only have one unknown is because we already know what the value of y is going to be once the ball strikes the floor. Okay, once the ball strikes the floor, y is going to be 0, right? That is, the height above the ground is going to be 0. So we can go ahead and plug in 0 for y, and we'll have 0 is equal to minus a half gt squared plus y0, okay, where y0 is the height of the tabletop. Now keep in mind that this height is already provided to us as 1.2 meters, okay? So using a little bit of algebra, we can solve for t squared, right, and then take the square root to get t. So we have 1/2 gt squared is equal to y0, and if we rearrange it a little bit, we have t squared is equal to 2 times y0 divided by g, okay? Which means that t is equal to the square root of 2y0 divided by g, okay? And if we plug in the numbers for y0 and g, we find that t is equal to 0.49 seconds, which is the answer to part A. Okay. Now, as for part B, we're asked what is its speed at the instant it leaves the table. Okay. So again, we go back to the tabletop and we keep in mind that the ball has only an initial x velocity, okay? No y velocity, because it rolls horizontally off the tabletop. Okay, so at this point, if we want to get the speed at the instant it leaves the table, that means we're looking for v0x, right? We're looking for the speed in the horizontal x direction, because that's the speed at which the ball leaves the tabletop. The good thing is, if we use this equation, right, we already have solved for t. We also know what x0 and x are. Okay, so x0 is the initial x distance of the ball. Okay, now we can choose this initial x distance to be 0. Okay, if we choose the edge of the tabletop to be at x equals 0, then we can write x0 equals 0 here, and we're already given that x is equal to 2.5 meters. Okay, so x is the landing distance from the edge of the table. Okay, so we have 2.5 meters here. Okay, so that means that we can rewrite that equation as, let me see if I'll have a little bit of space here. Maybe I'll erase these and then we can move the t over here. Okay, so we can write this equation as x is equal to v0x times t, okay, because we're considering x0 to be 0. All right, which means we can solve for v0x as v0x is equal to x divided by t. All right, the speed is equal to the distance traveled divided by the time. Okay, which means that if we plug in the value for the time and the 2.5 meters for the x, we find v0x. Let's see. Okay, so we find v0x to be 5.1 meters per second.